Hello everyone, welcome back to CFD College. I'm Ashkan, and in this video I'm going to solve some problems from Fluid Mechanics 1, Chapter 2. In this video I will cover Tutorial 2 of Fluid Mechanics 1 course in Concordia University. We have 3 problems regarding manometers, and I think it's useful for everyone, any students in mechanical engineering. So I hope you enjoy it and find this useful for yourself. So please subscribe to the channel. We have lots of videos on CFD using fluid mechanics, using ANSYS Fluent, from pre-processing up to post-processing, and they may be useful for you in future. So let's go to the problems. This is first problem of this tutorial, problem number 42 of chapter 2. Here, as you can see, we have a U-tube manometer which is connected to a closed tank. So this is a closed tank. The air pressure in the tank is 0.5 psi. So here we have pressure of 0.5 psi. And the liquid in the tank is oil. We know the specific weight of this oil. The pressure at point A here is 2 psi. So PA is 2 psi. We should find the depth of oil, Z, and the differential reading H on the manometer. So as you can see here, we have a closed tank, we have a manometer, here we have another liquid with a specific gravity of 3.05. Here we have opening, so here pressure is atmospheric pressure. As you can see, all the pressures are in psi, not psia, which means absolute. So as I always say to students, we mostly work with gauge pressures in fluid mechanics unless it is specified. Okay, as you know, here we don't have any flow, and we don't have any moving object, so everything is stationary. In these situations, we should know that we have hydrostatic pressure, which means that if we move downward, pressure increases, while if we move upward, pressure decreases. And the difference is gamma H. So if we move downward, we should add this gamma H. H is the depth or the distance of the movement. And if we move upward, we should subtract the hydrostatic pressure. Another point is when we have a closed tank, the pressure at the surface of liquid is equal to air pressure. This hydrostatic pressure, we only consider it in liquids. So if we have a liquid, for example, here we have P1, at this steps we have P2, which is greater than P1, and the difference is gamma H. So if we know P1, we can find P2. 2. If we have like this an open tank, P1, since we have atmospheric air here, P1 equals I'm sorry, P pressure of atmosphere. Since we are working with gauge pressure, here P1 is 0 in these cases. As you know, absolute pressure equals gauge pressure plus atmospheric pressure. So on the free surface of a liquid in an open tank, this tank is open, we have atmospheric pressure. So here we have PATM equals PG plus PATM. So PG, gauge pressure, equals 0. That's why P1 equals 0. But if we have a closed tank like this, here we have air mostly, and pressure of air is shown by this pressure gauge. Since gamma of gases is much smaller than gamma of liquids, we don't consider hydrostatic pressure. It means that pressure at this point equals pressure at this point, and at this point, this point, this point, this point. So air pressure is the same at in this region, and the pressure on this interface, the surface level of any liquid, I don't know if we have water or oil, equals air pressure. Okay, so now we can solve the problem. So in these kinds of problems, you have to find your key points first. Any interface is a key point in fluid mechanics. So here we have an interface between air and oil. Here we have an interface between these liquids. Here we have an interface between air, because here the manometer is open, and this liquid. So we have 3 key points. Okay, now here is point A, and also point A is another key point in this problem. Why? Because we know the pressure of this point. After identifying the key points, you have to move from one point towards the another and think about the movement, whether it's downward or upward, and then add or subtract the pressure difference. So for part A, we should find Z. So it's obvious that we have to move from this point, for example, point 1, up to point A. So if I move downward, I can reach point A. So we start from P1. Then, as you know, the movement is downward, so I have to add the pressure difference, which is Z times gamma of oil, equals, since I reached point A, so the right hand side is equal to pressure at point A. Now it's easy, because we know that P1 equals PA, because it's a closed tank, and it's always the same. Here, when we have an open tank, P1 equals pressure of air, and since air has the pressure of 1 atmosphere, so pressure is 0, because we are working with gauge pressure. So P1, which is PA 0.5 psi. Oh, let me find Z first. Z equals PA minus P1 divided by gamma of oil. Okay, now we can find Z. Z equals PA, which is 2 psi, pounds per inch square, minus P1, 0.5 pounds per inch square. We have to convert it to feet, I mean the inches. So 144 inches square equals 1 feet square. And in the denominator we have gamma of oil, which is 54 pounds per cubic feet. So Z equals 4 feet. This is part A. And for part B, we should find H. So you can move from this point, point 1, up to this point. For example, point 2. Or you can start from point A and then move towards point 2. You can't start from this point, point B, because you don't know the pressure at this point. So I prefer to go from point A up to point 2. So I start from point A, start moving up to reach any interface. So here I reach the first interface and I move downward for 2 feet. So I should add the pressure difference, gamma of oil times 2 feet. Then I keep moving from this point up to this point. So I moved upward for the distance of H. So I should subtract the pressure H times gamma of this liquid. I don't know that, but I know it, the specific gravity. So specific gravity times gamma of water give me the specific weight of this liquid. And then I reach point 2 and I know the pressure because it's an opening. So point 2 equals P2, which is 0. So from this equation I can find H. H equals PA plus gamma of oil times 2 feet divided by SG gamma of water. So H equals pressure at point A, 2 pounds per inch square times 144 inches square, 1 feet square, plus gamma of oil, 54 pounds per cubic feet times 2 feet divided by SG, 3.05 times gamma of water, 62.4 pounds per cubic feet. So H can be found as 2.08 feet. Okay, then now let's go to the second problem number 47. Now in this problem we have 2 open tanks, this one and this one. They are connected with this system So here we have water, and here we have a liquid with the SG of 0.9. Delta H, determine the elevation difference, delta H, this one. Okay, so as I mentioned, first step is to find key points. So we have two free surfaces, and free surface is a key point. So here we have our first key point, here we have the second one, and don't forget we have these points in between, but we know pressure at point A and also pressure at point B because we have open tank. Here is an open tank and here is another one, so PA equals PB equals 0 because we are working with gauge pressures. Okay, now let's start from point A and move towards point B. Let's see what we have in between. PA, pressure at point 1. Oh, sorry, PA, yes. Then start moving and follow the path until you reach the first interface here. So the movement from point A to this point is upward, and for example, let's call it H. So I moved upward for a distance of H. So minus H times gamma of water. Then keep moving from this point until the next interface, which is this one. Movement is downward for 0.4 meters. So I should add the pressure, 0.4 meters times SG times gamma of water. Then keep moving, and now I'm here at point B. If this is H and this is 0.4 meters, here is H minus 0.4 meters. And here is delta H. So the movement is downward. I should add the pressure. And the amount is H minus 0.4 meters plus delta H, and the liquid is water. And then we reach point B. But we know this is 0 and this is 0. So if you see here, we have minus H gamma of water. Here, if you multiply these terms, we have H times gamma of water with a positive sign. So these terms are vanished, they cancel each other. So what do we have in the end? We have 0.4 meters times SG times gamma of water minus 0.4 meters times gamma of water plus delta H times gamma of water equals 0. So we don't need to multiply specific weight of water to all these terms. Now we can find delta H. Delta H equals 0.4 meters minus 0.4 meters times SG. So delta H is 0.04 meters. It's so easy if you follow these steps. The third problem number 49. For the configuration shown in the figure below, what must be the value of a specific weight of the unknown fluid? Express your answer in pounds per cubic feet. Here we have an unknown fluid. We want to find gamma. We have water in this column, and in this column we have open ends on both sides of this manometer. And first we need to determine our T points. This is one of them, and this is the next one. Why? So this is point A and this is point B, because we know the pressure at point A and B. It's an opening at point B and also at point A, so we have atmospheric pressure at those points. Then we know PA equals PB equals 0. And we have two interfaces in between. So now you know that we have to start from point A or B and move towards B and A, B or A. I start from point A, PA. I move towards point B until I reach the first interface. I moved downward, so I should add the pressure plus gamma of water times this distance, which is 5.5 inches minus 1.4 inches. Then I keep moving from this point to this point. The movement is upward for this distance, so I should subtract the pressure gamma, which we should find it, times 3.3 inches minus 1.4 inches. Then I should continue the path upward, minus gamma of water times 4.9 inches minus 3.3 inches, and then I reach point B. So since we should find the specific weight in pounds per cubic feet, I should divide all these by 12 to get feet. So don't forget this. Okay, we know PA is 0 and also PB. So what we have is gamma equals gamma of water 62.4 pounds per cubic feet. Here we have 4.1. Here we have 1.9, and here we have 1.6. So this should be multiplied by 4.1 divided by 12 feet, minus 62.4. I'm writing this there, times pounds per cubic feet times 1.6 divided by 12 feet, and in the denominator we have 1.9 divided by 12 feet. So from this you can find gamma is equal to 82.1 pounds per cubic feet. I think it's enough for this tutorial. We have solved all the problems. So thank you for watching this video. Please subscribe to the channel, and if you find these videos useful, please share them with your friends. I would be happy to help. If you have any questions, you can write down your questions in the comment section below. And until the next video, take care of yourselves and bye bye.